We're in Boulder Canyon now, right at the top of the steep section in Boulder Canyon. And you can see the dramatic walls behind me that were left behind as this river has cut down rapidly. In fact, if you look at the channel next to me, the slope of the channel actually gets steeper as you go downstream. That's unusual. Rivers usually get less steep as you go downstream. So here's a place where it's getting more steep. We call that a nick point or a nick zone. That gives the river more power with which it can erode the rocks. We think this nick zone has been migrating upstream and leaving behind these steep rock walls that then lay back as they weather and erode over time. We have some beautiful examples of river erosion here in these rocks. You can see that the rock I'm standing on is very hard and beautifully rounded and smooth. And right next to it, look at this surface, this rounded surface. That's carved by, beaten by pieces of sediment carried by the channel, hit that surface, and gradually over time smooth it, abrade it into that form. And you can see all these little rocks down here. These are likely the abraders, and they get hit that rock carried by the water when it's up this high, and over time carve it out. So this is how a river can cut down through solid rock, is by throwing particles at its bed and abrading it piece by piece. Look at this. There's the abrader. This is a river-rounded piece of rock that was inside this pothole, and it's about, well, it's my whole hand depth down to the bottom of it. There's other sediment in there as well, but this is the big piece. And this pothole is because of vortices in the water when it's covering this rock, and they swirl around with sediment like this and simply grind away these potholes. That's the small-scale features, and the large-scale feature is the canyon itself that I'm standing in. That's the net result of that abrasion occurring over millennia.